So the really important part of this is going to be the flowchart, not the code so much, but the code will be fun. So if you want to type it in as well, that's fine. So alrighty, to make this easier, excuse me, we're going to declare the turtle outside of the functions so that we don't have to pass the turtle in as a parameter to each function. Just makes it a little bit easier. So we have to import the turtle. Now let's make a turtle. T is a good name for a turtle. Turtle with a capital T. And you could do all that business where you set the color of the screen and stuff like that, but I'm not going to bother doing that this time. Hey, where's my cursor? Come back. All right, let's make a function called relocate that will relocate the cursor to a specified X and Y position. So to relocate, we want to lift the pin underscore up. I should be double checking and correct my syntax. Uno momento. Turtle, pin up. Make sure I get that right. Because there may be an underscore, there may not be. We will find out. Yeah, no underscore and pin up. So we've lifted the pin, and now we're going to set the X coordinate and the Y coordinate. So T dot set X. Apparently it's not set X. That is. Don't know why. Oh well. Okay. We set the X position. We set the Y coordinate of it. And then we put the pin back down so we can keep drawing. Now to make a really well-behaved function, we should check to see if the pin is down before we start doing all this stuff, because if the pin is down, we want to lift the pin and then we want to set it back down. But if the pin is up, we don't want to set it back down. However, for these purposes, we'll just know that each time we call relocate, it's going to put the pin back down. We'll live with that. All right, now let's make a function which draws a triangle. So I'm going to call this one draw triangle. You know what, I'm just going to call it draw try to save myself some typing. And I care about the side length. And to make give myself easy typing, I'm just going to call it side. The way the triangle works is we need to draw 3 sides with an angle of 120 each side. So I'm going to create a variable called angle, and it's going to be set to 120. And now we need a counter variable, which is going to be the number of sides. So C let's make a variable called corners and set that to 3. And that'll be the maximum of our counter. And now we need a variable to be the counter. X is as good as anything, or C, something like that. We will set C equal to 1. And then we will have a while loop. While C is less than or equal to the number of corners, we want to go forward. T dot forward And by the way, some of these commands have abbreviations. We could abbreviate forward FD. I like the word forward, so I'm going to leave that. And I want to go that many pixels, side number of pixels. Then I want to turn. I think I'll turn left. And I want to turn that many degrees. Then I need to add one to our counter. So C plus equals 1. I think that's enough. So I'm going to do a return statement to bail out of our function. And I forgot to add return to relocate. And strictly speaking, if it's a void function, meaning it doesn't return anything, we could leave that keyword off. But I like seeing it. It makes it easier to look at. Alrighty. Let's go to the left half of the screen and draw a triangle. And then let's go up. You know, if we did this right, we could get a Triforce going, but okay. So let's do relocate. And since it's X on the horizontal axis and Y on the vertical axis, we're going to go like -200, comma 0. And what does a relocate function do? It lifts the pin, it sets our X coordinates, sets our Y coordinates, puts the pin back down. Now let's draw a triangle of maybe 100. Heck, let's make it 200. We're going to make a... Okay, now let's relocate to the right half of the screen. So we need a positive X value. And let's draw another triangle. And this might actually work. We may already have a Python script called triangle, but that's okay. We'll just write over it. Triangle.py is what I'm calling my file name. And I'm going to run it and see if I have any syntax errors. But that didn't look as cool as I was hoping. I'm going to change the X and the Y, the X coordinates to -100 and +100. That might look better. Cool enough. I can't help it. I'm going to take a stab at drawing the third part. Relocate to -50, comma, I don't know, 70. That's a total guess. And then draw one more triangle of the same size. And then I'll walk around and help y'all fix typos. Yeah, that was an admirable but failed effort. If I pushed it up, you know, anyways. Monkey with the coordinates once you get this done and see if you can get that other triangle perfectly positioned on it. That'll be a fun little project for those of y'all who have it running. Who? Okay.
Well, that's all right. We'll fix it. Okay. Why is it only drawing one side? I haven't spotted the problem yet. Oh, you have a return statement indented, which means it only draws one side before it returns. Unindent that. That'll draw three sides. Cool deal. I changed my values, so you can just look up here and see my new numbers. Right, when it was there, then it was inside the while loop. So all it did is draw one triangle and then instantly bail out.
So how would you quickly unindent that?
Oh, there's no way. Hit the backspace key there, see if it goes back. Yeah, yeah. Needs help. Okay, I see more than one person making the same thing. Look what happens if my return is indented. And then I run it. It only, yeah, it's not doing what I want. And the reason why is because if I have return indented, it's part of the while loop. So it does that, it does that, it does that, and then it instantly returns. It only drew one side. So we have to unindent the return statement to get it to work. You have to have parentheses after turtle.
Oh, duh. I was wondering why was it running.
Alright, now we have something else going on. That means that we have a program in your directory called Turtle. So do a file open. See if we have one named Turtle.
I'll hear like some bird.
I put the coordinates 0 and 175.
I mean, ah, set X, set Y. Sorry for the false confusing. That's you too. Alrighty, let's go back and look. Corner versus corners. We need to make the spelling the same. You have an S there. Haha. There we go. And I changed my coordinates, that's why yours aren't touching. Whoa. 0175. Okay.
Yeah, I got it from him.
Okay. Yes, ma'am. Well, show me. Go ahead and run.
So what?
Because when I started out at 100, it didn't get my code again, so I would just increment by 25.
Oh. You have to have the parentheses when you do turtle.turtle. If you don't have parentheses there, it's not going to work. Generally, when I see more than one person do the same thing, that's when I scamper back up there. Good. You have to do set X and then set Y. So you need an X before the parentheses as well. And then put it in the parentheses as well. Same for the Y, set Y. And mine
fill and infill.
It's
Change it to
between
begin underscore
like
fill.
Leo dot, or T dot, begin underscore fill, so I guess it's just begin underscore.
Let's go ahead and add the underscore. I think this is what, and then infill.
You could do that.
Yeah, so. You're gonna wanna take that infill off, there's some infill.
Are y'all doing? Anybody else need help? Yeah, I see some people putting colors in theirs now. That's cool. Let's make it so that each triangle gets filled.
So what we want to do is we want to start our fill as soon as we go into draw triangle, and we want to end our fill before we return. So we're going to put something here, and then we're going to put something here. Or we could just stick it above the while statement, but I think it'll be most obvious if I do it here. T dot begin underscore fill at the beginning of our triangle, and then right before our return statement, and make sure it's not indented, T dot end fill. Now when we run it, our triangles will be filled. All right, so somebody tell me the coordinates for the third triangle.
0 and 175.
Cool. So if you want the third triangle and you hadn't already figured it out, it's at position 0, 175. And if we wanted to, we could work more, at centering it, but that's really enough to prove the point. If we want to change the color of the triangle, you would want to change it before you started drawing anything. So maybe above our first relocate, let's add T dot color. Oh gee, what color might I make it? Yellow or green? Green.
You said we were supposed to do that above the while statement, right?
Right, begin fill goes above the while and end fill goes below it. Like that. That's what we added first, and that's what we added next. All right, that's enough to make an interesting flowchart. This flowchart will illustrate two important principles. One is flowcharting a function, which we did on Monday. We did several of them. And then the other is flowcharting a loop. And since we've already done functions, the loop would actually be the more important thing to flowchart. So when we draw our flowchart, the top circle for the draw try function is going to have the name of the function, draw try, rather than just the word start. And then the last one, instead of saying stop, it'll have return. So let's go into Lucidchart. Make a blank diagram. Now relocate's pretty simple. So we will do DEF relocate, parentheses X comma Y. And since we didn't invent these functions, we're not going to put them in the function box. Instead, we're going to just put them in ordinary process boxes. T.pinup. And really, I should probably put all of these in separate boxes, but instead I'm going to put them in one box. That's kind of lame. But since they're all kind of the same thing, I really shouldn't do this. No, I lied. I'm gonna make this a good flowchart. So lift the pin, set X. And then set Y. To speed up the drawing a little bit, I copied set X and pasted it. Then we want to put the pin down. Again, I'm going to copy pin up and just change that. So select it, Control C for copy, Control V for paste. And then a return. Now for the important one, the loop. I'll draw the loop up here first. The way the loop looks is it looks like an if statement. So it's in a diamond, but the end of the loop points back up to itself. So it goes into here. We have a lousy pen. I would put while blah blah blah. And while that's true, can't believe I misspelled true. Then we do some stuff, we increment our counter or whatever it is, and then we hook back up like that. And then our false is like that. And so you can see the essence of a while loop. As long as it's true, it keeps repeating over and over and over. Like that. Only when we're done do we bail out and do something else down here. So that's how we're going to draw our while loop. Just like that. We're going to have a diamond. We're going to have some instructions. Actually, 1, 2, 3 instructions. And then we're going to loop back up to the while. And you will see textbooks leave off the word while and leave off the word if. But I think it makes the flowchart a lot clearer if we go ahead and put while and if. So if you want to leave them off, that's okay, but I'd rather see them. So we're going to do the draw try function. We need another start block. DEF, draw try. What's the first thing that happens? We begin to fill, we set the angle, we set the corners, and we set C is equal to 1. These three things are so similar, I am going to put them in the same box. They're just 3 assignments. Whoops, I did not mean to close that. Come back. So the first one, T.begin fill. And the code might have looked a little bit better logically if we put that right above the while loop rather than at the top of the function, but I think you get the idea either way. So these assignments are also done in math blocks and process blocks. Angle is equal to 120, and then I hit Control Enter to go to the next line in the same box. Corners is equal to 3. Control Enter, C is equal to 1. And why am I going ahead and doing all 3 of those in the same box? Because they're all 3 the same operation. They're identical operations. It's just simple math. So I feel comfortable doing that. Don't put a assignment here and then a plus, you know, on the next line and then some other complex calculation all in the same box. But when you just have multiple assignments, I don't see any problem with doing it that way. Again, that's not strictly correct, but I think it's clear enough to us.
Why do these are going to predefined process boxes?
I goofed up. I forgot to put a number there. Which ones do you think ought to be in predefined? And you're not necessarily wrong.
Well, everything between the define, relocate, and return.
We could call that a predefined. We could call that a predefined. We could call that because they're all function calls. But in my opinion, I only want to highlight our own function calls, the ones that we wrote. So I'm just going to stick these in process blocks. And I reserve the block with bars for when we're going to call draw, try, or relocate. Now I left something off draw, try. I left off this parameter side here. So I need to go back into my parentheses and add side there. All right, now we're ready for our while loop. While is done in a decision block, just like if. While, and I'm going to just hit enter, so I'm typing on the next line. C is less than or equal to corners. Now, it doesn't really matter which way you make these lines go, the true and the false lines. But I always like to make my true lines for an if statement or a while statement go off to the right. And the reason I do that is because when we're typing our code, we indent. So I'm going to mimic that by shifting to the right here. So my true line is going to go off to the right. I'm going to go ahead and scroll this relocate function off. I hope y'all are done with it. There. I could probably get a little bit more of this on the same by squeezing them together. Okay, so while C is less than corners, hey, come back. T dot forward is going to be a process block. And by the way, that was a great question because you could argue that these should be in process in predefined function calls as well. T dot forward, parentheses side, and we want to make a line from our while block to there. Doesn't really matter how you draw it. But the rest of these I'm going to put going straight down. Just like this code, you know. T dot left follows T dot forward underneath it. And then C++ plus 1 follows that. And I go to a lot of effort to keep as much on the screen as possible, so I'll try to squeeze all my flowchart together. When you're drawing these, you don't have to do that. And then lastly, the math. C is equal to C plus 1. C plus equals 1. And then the no part of the while, the false part, when we're no longer in it, comes down here and it calls T dot end fill. And then there's a return. Now I've got a problem. I left a dead end. If you've got a dead end in your flowchart, you won't get full credit for the flowchart. So I have to make this thing loop back up to the while. And I try to, I mean, how you make it loop back up is your choice, but here's what I usually do. I draw a line from there and I try to hook it up into the middle of the, like that. It's kind of tricky to get it to do that, but here we go. All right, those are my two functions. Now I need to do the main code. The main code is the code that's not indented. In some languages, you actually write another function called main, and you stick all that stuff in it. But we don't need to do that. But we are going to start a new column of lines, and we're going to put start at the top and stop at the bottom. And I'm just going to hope that I can remember this stuff because we need more room on our flowchart now. I may ask y'all to help me with that. Alrighty, I'm going to scroll this over. I'm going to hide that stuff. And it doesn't really matter whether you go and put this underneath the code or on the next page or whatever. But we do need a start block. Really do kind of need to see my code. Not the triangles, I need to see the code. That'll probably be enough to clue me in. Okay. Now really, it looks like the first line of our main program is this, t.color. But honestly, the first line of our program, of our main code, is way up here, where we create the turtle and where we import it. So we're going to stick those up as the first steps of our start. And do you see why I say those are really the first lines? These are unindented. These are unindented, so they're all part of the main program. I think I'm going to leave off the import turtle statement, but if I was writing this for y'all to program from, I would probably put it in there just as a reminder. But I'm just going to go t is equal to turtle.turtle. If you want to add another block for that import and put it between start and the new turtle, that's totally cool as well. To me, the import is not as important as the logic. All right, now I need to scroll back down to see what the calls to our functions were. We set the turtle to a color, at least I did. But I'm going to leave, I'm going to stop leaving things off. Okay, t.color green. Now to me the turtle library is a little illogical. If it's set X and set Y, it ought to be set color. But it saves us some typing, just getting to type color. All right, now that we've done our color setting, we can call our relocate function, which was at -100, 0. Now we're actually calling one of our own functions, so we're going to use a predefined process block. So relocate -100, 0. And just because I like to color code my functions, I'm going to make my relocate terminal pink or blue or something. And I'm going to make the call to it blue. I'm using a paint bucket for that. So, thinking ahead, I know that draw try, I'm going to make a different color. I'm just going to fill that in with yellow. Again, the colors are not important. All right, the next line was to call the draw try function. So I need another predefined process block. Draw try with a side length of 200. And that needs to be yellow. Well, it doesn't have to be, but that's what I colored that. Then we had 2 more calls to relocate and draw try. So add those underneath these 2 calls. And then put a stop at the bottom. I'm going to leave that off because I'm going to walk around and make sure that nobody's having trouble drawing so far. I'll come back and add it. See anybody having any problems with this? Yeah, like I said, I smoothed everything as tightly together, just have to get on one page, but you don't have to go to as much effort unless you just want to make it look pretty.
Is yours still in?
Yeah, see.
No.
You
Both
were-
of our computers shut off. Mine, don't think mine.
During the, whenever you started up this, ours just shut down for some reason. No reason at all.
Oh, well,
And, now I still have all my stuff.
that is totally lousy. I apologize for that. I don't know why it would do that. So if you need the code again, I could pop that up.
Wait, how much of yours saved? All of it.
Oh, it saves every time you run it, doesn't it?
Right.
That's good then. We're fine.
So what I did is I selected 2 boxes. I did Control C for copy, Control V like vehicle for paste. And that's just saving me some copy paste time, and I changed the numbers. And then a return at the bottom. And I really need a line going all the way down here. I'm going to save some time and stretch one of these lines. Cheating. If I can select that point. No, it's not letting me. You know what, I'm going to delete it then. Redraw it, come all the way down here, and then I'm going to select that line, right click and do send to back. There. fast way to do that. All right, guys, I'm going to create some code that has a loop in it, and I'm going to ask y'all to flowchart it. It's going to be a very short program, so don't sweat this. We're curious how long at 10% interest it's going to take for our investment to double. So we're going to give ourselves an investment of $1,000. We're going to set our target equal to $2,000. We're going to set our interest equal, and you don't need to type this in, I just want you to flowchart it, but I'll post the code if you want to do it. Our interest is going to be 10%. So while our principal is less than our target, then our interest earned, i.e., is equal to principal times the interest. And then the principal gets increased by that much. And let's print out our new amount. Now we don't have a counter for the year, so I'm going to make a year counter. I'm changing the year variable to 0. Okay. And then I'm going to print the years. That just tells us how many years. Going to change the print statement to print both the year and the principal. Call this interest.py. Let's run it, make sure it works. Y is not defined. Okay, that's because I called it year. Excuse me. There we go. Run it again. And dude. All right, that didn't work. Oh, why do I have P plus IE? It should be plus equals. Okay. All right, so it took 8 years at 10% interest. Now you show me a bank account that earns 10% interest, I'll be impressed. But there we go. Go ahead and flowchart that. Just make a new flowchart. Put a start up at the top, a stop at the bottom. If you want to put all 4 of these commands in one block, that's okay. But I'd rather you not put anything else in one block. So I'm not going to do this one for y'all. I'll let y'all finish this one. Hopefully this will only take about 10 minutes and we can do a little bit of... Did we say our exam was Tuesday or Thursday?
You said Monday.
Yeah.
Well, yeah, why am I saying Tuesday and Thursday?
Class?
Wrong class. Okay. Let's go ahead and do it Monday. I think we can prepare for it, especially since it's open book, open notes, that kind of stuff. So when you draw your flowchart for this, go ahead and do download as, save it as a PDF, and I'll make a Dropbox for you. If you want to put the other PDF in there for safekeeping as well, that's also totally cool. This one, let's call it interest. All right, there's a drop box in the in-class section, in class 7. I've only given y'all 3 homework assignments. I've been lax. Tell you what, the next unit's going to be brutal, man. No, I'm kidding. But I do need to give y'all more homework. But we've been just kind of covering the basics. Now, I think would be more appropriate to actually start assigning scripts and stuff like that. But not before the exam. Bless you. Yeah, I see some wild loops that are all quite well done. I would actually like it if these 3 things were broken out. And the reason why is that initializing variables isn't nearly as important as this is the key to the program. That's the algorithm for calculating the interest. So I'd like to see those broken out. I shouldn't have even stuck anything in the same box. Exactly. Right. Yeah, the stop's going to go at the very bottom after the print year. Yep, no, got it. Just remember that your while loop, after all that stuff, here's the lousy pen again, has to point back up to itself. So while, blah, blah, blah. And if you wanted to draw it hooking up back to the top rather than to the diagonal, that'd be okay. That's your true block. And this is your false.
In the program, where did you define E at? I didn't know.
I don't have any. I have IE,
Well,
which I declare
okay.
right there. Yeah, yeah. And if I was a good programmer, I would have actually documented all of these things. So since I'm going to upload this code, I'm going to go ahead and add some. That's our principal, that's our goal, that's our interest rate, that's our years that have passed. This is calculating interest. You know, I could actually. And then add it onto the principal. I'm going to use a programmer term. We increment the year when we add 1 to it. Decrement is when you subtract 1 from something. Well, that's odd. Each time I hit tab, it's doing something weird. And I made a fancier print statement. You don't need to change your flowchart to match it. Nah, I'm going to remove that. There we go. And you certainly don't need to add the comments to the flowchart. If you wanted to, you could use those braces.
Since this doesn't return or anything, would it end with?
It ends in a stop.
Yeah, okay.
Right, so draw a box down going to a stop. You don't have your print yet though. Print your year underneath the no block right here, and then put your stop under it.
That's all it is.
This one was much simpler because it didn't have any predefined functions. Yeah, that's cool. So I'm sure you know this, but eventually you're gonna have a line hooking that one up and that one. Because you've got a dead end right now, so just draw a line. Yeah, that's cool. All right, guys, I'm going to go ahead and skip to the review. If you're not done with your PDF, yes, sir.
At the bottom, you said print year and then years.
Right.
What is years equal to?
The reason I put the plural there, here, let me show you the output.
Oh, because it'll be like a.
It's just so it says 8 years.
Oh, okay.
Yeah, yeah. I really would like a big message, you know. It took 8 years to achieve your goal. But since we were flowcharting, I made it itty-bitty. All right. So what are we going to do on the exam? Pretty much this covers. You might want to take notes, maybe. Pretty much this covers, well, I guess I could type it and upload it. But chapters 1 through 4 of how to think like a computer scientist. Specifically, like what kind of data type is a number like that? Is that a float or an int? Yeah, that's a float. Ditto for something like that. That's an int. How about if I put quotes around it? That's a string. That's enough. Those 3 data types are enough for now. How to draw a flowchart. What is the terminal? That's the oval. What does a math process block look like? That's the rectangle. What's the if, the decision, and the while look like? Yeah, that's a diamond. Have we had another one? Yeah, input and output, prints, and you,
Arrow.
We may not have reinforced that in on the flowchart you just drew, but really, the input and the prints should be in the quadrilateral, the rhombus. It's not too late to change that. But if you've already saved your document, that's okay. Also, we did a worksheet on binary and hex, like your worksheet. Did we do ASCII in this class? Okay, then we won't do it on the exam either. Now, some stuff that we have covered that aren't in chapters 1 through 4, but we did it anyways just because it was important, was the while loop. I'm not going to ask too many questions on it, but if I ask you to flowchart something, I might give you a while loop on it. And the if and the if else. Excuse me, we haven't done else. Yeah, we have. We haven't done elif. But I think we've done if and if else. We did elif too, right? Because we did a are you too young, too old, or just right?
No, we didn't do that.
We didn't do that? Well, we had to have done an if because we've already done a diamond. How does an if work? You just put a condition in here, like x is equal to input, what is your age? Then you convert that to an int or a float. And then if x is less than 18, we're going to print, go back to school. That's the way an if works. And you draw it with a diamond, but then the things come back together at the bottom. So, looking at this, we need to know how to get input, how to convert it to an int or a float. The syntax is the same, but you replace the word int to a float. How to print, how to write an if statement, and if I give you code for drawing a triangle versus drawing a square, just be able to tell the difference. You know, I might say, what is this going to draw? And you go, oh, that's going to be a triangle. How do you know? It's only got 3 sides and it's going 120. I'm not going to ask you to write the code for drawing a triangle. I'll just give it to you and make you, tell me. Know whether some code draws a triangle or a square. All right, we've done some math. So know what each one of these would do. 3 plus 2, 3 divided by 2, what would that equal? 3, minus 2, 3 times 2, and 3 modulus 2. And what each one of those is called? Well, especially modulus. The rest of them are so obvious. Know that a is equal to a plus 1 could also be rewritten as a plus equals 1. And is called incrementing. All right, I'm actually not going to upload these notes, but they'll be in the video, so if you go and watch the last 10 minutes of the video, you'll see them again for your review. So then I'm going to give you some code and ask you to draw a flowchart. Draw a flowchart. It may have a while loop, it may not. So just as a refresher, let's draw a flowchart that has an if statement in it. An if statement looks like this. It's got some code above it, blah, blah, blah. And then it's got an if. If, and then the condition. X is less than 10, or if X equals blah, blah, blah. And it's got a true and a false side. The true may come over here and print something, in which case I would use a quadrilateral. Print. It's less than 10. It's looking really lousy, but you get the idea. And then the no side, if it's an else, will come out to the that, but if it's not an else, it's just going to drop straight down, and then they have to hook back up like that. And you know what, you're right. I'm not sure I made y'all flowchart an if. Okay, then I won't make you do an if when you draw your own your own flowchart, but I'll ask you what that shape is. You know, if I give you a diamond, just put that it's a decision block or that it's an if for a while. And it'll be multiple choice, so it won't be too hard to guess that. But that's how you do it. And do remember that inputs and outputs are done in the quadrilaterals. So if we wanted to throw an input in, I could do this. I could put it in a quadrilateral. I'm going to just right click and do change shape. Pick quadrilateral. X is equal to input, enter X, and then I would want to convert it to an int or a float underneath that. Because anytime you get numeric input, you have to do both steps in Python. You get a string, and then you convert it to an int or float. X is equal to int X. I don't think I'm going to make you write any code this time. We haven't had enough homework where you're writing code to justify that. But I do want you to know the concepts, and I want you to know what the code looks like, because I may give you a snippet of code and ask you what the result is. Mostly math, you know. Modulus and that kind of stuff. So that's our if statement. Not that I'm going to make you draw it, but there you go. All right, let's bring the rest of the notes back up on the screen. Make sure that we got them all. We know the three data types. We know that it has to end in a begin and end in an oval, which is called the terminal. Math or processes are in rectangles. Decisions, yeah. Important is flowcharts for functions, which is the process, predefined process. So it's open book. It's open to anything that we've linked to in D2L. It's not open to emailing your neighbors. You laugh, but okay. So a predefined process block. And we know what all these shapes look like.
And you said you're not uploading this, right?
I'm not uploading these notes. They're in the last 10 minutes of the video, so you'll be able to go back and take notes from them if you want. Or I'll leave them on the screen, and if you want to hang out for 5 or 10 minutes writing them and stuff like that, that's cool as well. So if I ask a question about what a while loop flowchart looks like, I might draw a while or I might draw an if, and I'll just ask you which one's which. And just as a, I'm leaning 75% towards asking you if, you know, the answer would be while. But you'll know. If it goes back up to the while, to the decision block, you know it's a while. All right, guys, I think that's enough. I'll upload the video so you can review, like I said, the last 10 or 11 minutes. y'all can finish and do download as PDF into your flowchart. So I'll see y'all Monday. Oh, and by the way, if you have questions during the exam, just raise your hand or yell at me and I'll come help you. I probably won't give you the answer, but at least I'll give you guidance.